this lesson we'll be discussing domain and range. By the end of the lesson, you should be able to identify the domain and range of a function or relation and write the domain and range as an inequality. So function notation means that the x are the elements of the domain and f of x are the elements of the range. So we change to intercept form and change the y to f of x. Y and f of x mean the same thing. So the difference between continuous and discrete, continuous means there's no interruption in the domain and range. It's just a flow from beginning to end. Discrete means that there are specific points and we just list those in our domain and range in braces, or make sure to write them from least to greatest, and there's no reason to repeat the same number. So when you're writing the domain and range as an inequality, this is for the continuous, right? The first number is where the line starts, and the second is where it ends. And then you put the variable in the center. If it's a closed circle, that means it includes the number, and that's when you have your greater than equal to and less than or equal to. And when it's an open circle, it means it doesn't include it, so you just write greater than or less than. So for example, when we have this domain and it starts at 0 with a closed circle and ends at 4, we would say 0 is less than or equal to x, which is less than 4. In this example, we're going to start here at -1 with an open circle, but it goes to infinity. So we could write it either way. You could just say x is greater than -1, or you could say -1 is less than x, which is less than infinity. So for example, identify the domain and range and write them as an inequality. So when we're doing our domain, if we highlight the one side of the box, or our beginning number and our end number, we're kind of making a box here with our domain and range. So if we make this line here, the smallest number in our domain is 0, and the largest is 7. So we would say our inequality is 0 is less than or equal to x, which is less than or equal to 7. That's our domain. With the range, we're going on the y here, so we're going to do the top and bottom. So this completes our box here. And the smallest number down here is -2, and the largest is 4. So our inequality is -2 is less than or equal to x, which is less than or equal to 4, and this is our range. So find the domain and range and decide whether it's a function. So in this first one, it is discrete. It's telling us that it's discrete. So our domain is just those points listed in order from least to greatest. And our range is also all the y points, the y of the ordered pair. And so yes, it is a function. In this table, again, it's telling you it's discrete, so it's not going any further than these numbers. So the domain is 0, 2, 4, 8, 10, and the range would be -1, 1, 5. Notice that there are 3 ones, but I'm only writing it once. In this one, this graph here is continuous. You can see it has an open circle to start with and a closed circle to finish. So our domain on our x, so we're looking at our x values, -6 to +1. It does not include -6, but does include 1. Our range, we look at the y values, it's going from 1 to 6. So 1 is less than y, which is less than or equal to 6. This table, it's telling you it's a continuous. So if we look at our x values, that means it's going to keep going in both directions. So that's going to be our -infinity to +infinity. The range, can you see that 0's in the middle, and then above and below is 1, above and below is 4, above and below is 9? That means it's a parabola. So our domain is all real numbers, or -infinity to +infinity, and our range is anything greater than 0. State the domain and range as an inequality. So our g of x, so that's the red one. So our domain, see how the arrows keep going? That's going to be all real numbers, or from negative to +infinity. And our range is anything less than 3. So it could say -infinity is less than y, which is less than or equal to 3. Or it could just say y is less than or equal to 3. The f of x, which is the blue line here, We're going to make our box sort of around it to help us identify the domain and range. So our domain goes from -5 to +5, including those. And our range is from -1 to +1. That's the top and the bottom. So looking at these, just trying to decide continuous or discrete. So in this one, we can definitely tell it's continuous. And this one we can definitely tell is discrete because it just has the numbers. Now these two tables are a little harder. We can see that the x is 3, 4, 5, 6, 3, 4, 5, 6 on both of them. Over here, it's 10, 5, 8, 3. See how those are sort of random? Where over here, it's 10, 9, 8, 7. So this one is more likely to be continuous and this one discrete. So is f of x the domain or range? Those are the range. Those are the y values. Remember, f of x is y. Is the table continuous or discrete? Well, our x values definitely go in a row. And then look at the y values. I'm definitely seeing a pattern, so I'm going to go with continuous.